All right, then good evening or good afternoon, and welcome to my talk. From what I heard in the keynote, like in the opening note this morning, that starting from shortly after 5, people will start serving beer. So that basically puts me into the unfortunate position to be the last one between like you and the beers for now. But so you have to probably hang out for this one. So yeah, thanks for coming. This one will be about observability in the Kubernetes space with a particular focus on JVM-based applications. So before I go into the topic, maybe a few words about myself. This is me. My name is Matthias. I'm actually not from far away from here. I'm from the city of Stuttgart in Germany. So that also means later on, if you have questions, you can feel free to ask them in Swiss German. I might be able to understand that. Besides my normal job at Novatech, where I try to help people on their cloud native journey and adapt to cloud native technologies, I'm also teaching at 2 universities in the area of distributed systems and modern software architecture. So a lot of the inputs from my talks also basically originate out of my lectures. And yeah, one thing I additionally want to highlight, I said I try to help people adopting cloud native strategy. I also teach a lot in the client space. So when there was the question in the talk before, how many people do actually use Kubernetes, there was quite a good amount of hands. So if you're not there yet, but if you want to, we also teach classes on Kubernetes and also for the certifications of Kubernetes application developer. So if you're into that, feel free and see me. I'm sure we can arrange something. All right, now I'm going to show this later again. Also on this talk, I only have 45 minutes, which is not so much. Especially if you see later on how many technologies are in that space of observability. An earlier version of this talk I have done with my friend Tiffany last year at DevOps Belgium as a deep dive 3-hour session. So if you are interested in any of the technologies that I'm kind of touching here and you want to see more, you might want to check this out. The only thing that I noticed just recently, if you put in DevOps in Google for my name, you won't find it because you might see that it chopped off the last character. So my name is not Haeussle, it's actually Haeussle. So that might be tricky to find it. But if you say look for DevOps and Matthias, I think you should be fine. All right, now focus more on the content. As I said, observability, Kubernetes, Java, this gives a lot of room for things to talk about and to look into. And yeah, before I basically browse around the technologies, I will also try to narrow down the problem that we're currently having here, and before I go into the various solutions. So who in here has been to a Neles talk in the afternoon about micrometer? A few? Okay. So this is actually a good match because I'm not going to talk about micrometer today, so this was already covered. But there will still be, of course, a couple of overlaps. So I really try to make this going hand in hand well. Now, yeah, as I said, the thing that makes monitoring Kubernetes tricky are that there are different ways to get into the information in the cluster. There are different levels or let's say depths, how to get in there and what you want to know, and basically how much you are willing to invest to find that out. And I'm going to introduce some of them here. So overall, I would like to guide you from bottom left to top right. So especially people starting with Kubernetes or monitor, or having large environments often struggle to get an overview and to figure out what is going on in their environment. And I hope to show you some things that will make your life easier there. Now, why is this so hard? I mean, in general, Kubernetes is basically a multi-layered architecture. You have distributed system or distributed architecture on the runtime, let's say the worker nodes where your things are running on. And very often you will have also a distributed and potentially polyglot application workload layer. So various services, potentially microservices written in different languages. I mean, this kind of slide has a bit of a focus on Java here, but in general, you might run pretty much everything that runs well in a container, which makes the thing a bit harder. In addition to that, you have the Kubernetes API object. So when you start Kubernetes, it's a bit like a new language that you learn. There are a couple of things you need to know. What do they model? How will they behave? This is also something you, of course, need to have clarity of. And additionally, just not doing this all on an individual level, you would also want to know who is basically talking to whom. Are my connections working well? Is something saturated? Is something not working at all? This information is something you might not get from like monitoring just of individual components. So that also gives us a couple of, as I said, depths or layers where you can plug in and try to figure out the things that happen in your environment. So the innermost layer would basically be the application layer. Then the applications are being wrapped in a container. The containers are being run in pods, and pods are being run on nodes. So I would kind of expect that most people have heard those terms before. Still, I want to try to make sure that this kind of nesting structure is understood. Once you want to observe that, of course, you can reach out to various levels and get information from different sources. There's the API server running on the control plane, and then the various levels of your application, container, pod, and node. So, and each of them have options of placing so-called agents or observability solutions that can collect information. And the idea of this talk is basically to see which level would provide me with which depth of information on the one hand, and on the other hand, the level of intrusiveness. That basically means how much do I need to change in the cluster or in the application or in the container. So this should give you a bit of an adjustment to say, okay, this is what I'm willing to do, and in return, this is what I'm probably about to get. Now, tools. There are plenty of tools. We have heard a couple of talks about Kubernetes today, but I don't think somebody has shown the CNCF landscape. I'm doing this now. So most people have come across this. This is basically an overview of all the cloud native technology in the Cloud Native Community Foundation. This is actually an old version. This was still in landscape mode. The technologies have gotten so many that they're now in portrait mode, so you can scroll a lot more. This one fit better to my screen, so I left the old version. And there's a categorization in there to say, okay, we have things for container, for runtimes, for various things. And there is also one for observability and analysis. Now, if you drill deeper into that, and this is basically a screenshot of the newer version, you can see that only in that scope of technologies, you still have a lot. And the 45 minutes will never be enough to go over all of these. So I'll try to categorize a little bit and highlight a few that I basically have most experience with and can probably answer the most questions. But you will see things like Spring Cloud Sleuth. So we had a lot of Spring topics today. And I still even have to go down now. I think I saw Micrometer before. I'm not seeing it anymore, but it certainly is around. We'll see. We're going to get to a few. Now, we start from the level of least intrusiveness. So basically from a perspective where everyone can start as soon basically as you have a Kubernetes cluster. So this basically means you're doing API calls to the API server and basically displaying the information what you have there. So the first steps you're going to do is most likely using the kubectl API. There you have things like get, describe, logs, and so on that will give out information about the various workloads in such an environment. However, there are some tools around which basically using the same level of API. There's some web tools, some fat client tools, and some which are as well based on the command line interface. And in an earlier version of this talk, I was still highlighting things like Octant from VMware and weaveworks Scope, Lens, and so on. And over time, I noticed, okay, some of them got out of fashion. Some got deprecated, discontinued, some went into the commercial space. So there is a lot of fluctuation there, which makes the thing even more challenging for the users. Now, K9s, the one bottom left, has always been a good open source friend. This was always around, and I'm really using this a lot. In turn, there have been a few new kits coming around. So Headlamp and Schooner are two that I didn't know, that I just basically picked from that landscape and started to play with. But basically, they kind of underline my story here. I mean, in the end, these tools are not going to give you anything that you wouldn't be able to do without by just using kubectl. It's just like, in some ways, they aggregate and format the data for you to navigate easier to the things that are running. Especially if you have a lot of resources in your environment, it's going to be can be hard to navigate through them. So this is k9s, or k9s, as it is properly pronounced. I also, let me just see, I have this as a live demo, so if you want, so basically you just need your kubectl context, then you pop in, and then you can basically browse through your resources. It will quickly highlight you if things are going well or if something is crashing. So you get like a high-level indicator of things that might go wrong. And it's like a bit of, like, the old people might understand that, still like a bit of a Norton commander in the Kubernetes space. I can't do all of the things live, but I just wanted to give you the idea, kind of. So this is like a web interface that was provided by Octant. As I said, this one has unfortunately been discontinued. This is Lens. This is Headlamp. In the end, they kind of do all the same. I mean, with the web-based ones, it's a little bit more elegant than on command line because they have easier navigation menus where they can basically summarize or build tree structures of the objects, and you can basically jump in there and basically display the information that it's giving. One of the cool things is that you can actually execute shells into your containers out of the web browser. So if you don't have like a direct shell connection and you only have a browser, this can be pretty helpful. In turn, of course, it means you need a browser. If you only have a shell connection, then something like that might be your thing. I mean, this one is kind of basically which I'm using all the time. The other one depends if I can. All right. So we've asked before, how many people using Kubernetes in here? Okay, so that's good. How many of you do know the kubectl debug command? Okay, it's getting more. When I asked this question half a year ago, there were not so many hands. It just has been added to the API, and well, it's not just. I think it was 123, but it's still fairly new. And what you can do with this one, for those who don't know, you can basically, if you say this is your application container here, and this application container is lacking of some binaries, then you can attach basically an additional container which doesn't start a new container process, but it will provide like functionality that the application container can use. So for example, if I go back to my environment here, and I have I can show you this here. I have a distroless container. So for people that don't know what that is, it's like a container that doesn't have a Linux distribution underneath, so it doesn't really have many binaries. So for example, you can't open a shell there, and it makes it very secure because it doesn't carry around stuff that you might have problems with later on. But in turn, it makes it really hard to debug this one. So let's say I'm going to do the Kubernetes command here. I'm just going to put it on the top and say I want to execute a shell into that container. And it will tell me it can't because bin.sh is not a process which is available in that container space. If I do, for example, let's say something really trivial, env or so, it doesn't let me. So those containers are pretty safe, but pretty hard to debug. If I now try to do this debug command, and the real reason why I tried this out was a colleague asked me if I know about a base container which would have htop installed to monitor like the individual processes better. I said, I don't, but with this you could actually get there. So now I'm suddenly in that container. Now I can do the things. I have a shell, I can do an env, and I could, for example, also run an htop. And this is basically from a container which before did not have all those binaries. So it is as dangerous as it looks. Don't enable this in production, of course, unless you have a very certain need to dig into one container. But if you have that need, this can be super helpful. All right, so this kind of sums it up from the things that we can do in the space of Kubernetes API. I think the tools will basically grow along with the possibilities that the API provides. This is not intrusive at all. I mean, you don't have to modify anything in your cluster. You don't have to install new things. And it's particularly helpful for people that just basically getting started with Kubernetes. But of course, with that, you also have some downsides. I mean, you wouldn't be able to discover like a ghost process. If Kubernetes shows something as running and you don't have like a liveness probe or something like that, you wouldn't really see it straight away that something is wrong there. You also don't see how the services interact with each other. So if two services are running healthy, you still don't know how much like messages are going back and forth, what is the latency, and so on. So this is clearly missing once you want to go deeper into that application space. Okay, just sip the drink. Now, Prometheus and Grafana were actually not part of this presentation originally, but you can't really talk about Kubernetes observability without mentioning Prometheus and Grafana, because those tools have been around for pretty much exactly that purpose all the way since Kubernetes exists. Now, they're not observability solutions by default. So Prometheus is more like a database, like a time series database, and Grafana is like a customizable dashboard which can like get the information from that database and visualize it for you. So basically, those two live from the information that certain agents will give them. They're not like a solution by itself. And we will later on see examples where they are being leveraged and used. So this is just as a side note that I wanted to make here real quick. All right. So the next one I'm going to look into is the level of pods. So we go from the Kubernetes API to a level of pods and see what we can do there to get information out of our running container environment. Now, before I go into that, people being more familiar with all that might probably think at this point, well, service mesh is most likely not the number one thing that I would think of if I think of Kubernetes observability. And same thing was actually true for me. And this was, I think, a survey that the company of Isovalent with the Cilium technology did in 2003, what people would be interested in of a service mesh. And by big surprise, basically the one must-have feature was actually observability. I mean, a service mesh can do a lot more, like controlling all the traffic, do routing, security, circuit breaking, retries, and so on. But observability is something that basically comes out of the technology kind of for free, and people actually do use it a lot. Now, how does this work? Most of you, as I said, I would expect those who raised their hands, know that in Kubernetes, applications run in containers, and those containers run in a pod. Kubernetes provides the option to run multiple containers in pods, so you can put many in there. And they would actually share the same network. So they share the same IP address and they have one common port range, and they can talk to each other with localhost. They also share the same underlying file system. So why is this important here? Normally, I would never recommend to put multiple application containers into one pod, because you eliminate the possibility to scale them individually and schedule them individually, so you take away some of the Kubernetes benefits. What makes still sense is using one of them as kind of a proxy container, where you say, okay, as I know the traffic that comes in there will always go to both of them, that means that the proxy container can actually do some supporting feature for the application. So it could, for one, block the traffic, and in case there is like too much traffic incoming, it could throttle, it could route it anywhere else. But it could simply just also listen and see what is actually the traffic going in and out of the application. Now, it doesn't make a whole lot of sense to do this in only one, but if you do that in many different pods, you basically have the ability to collect all of the network information that is going through your cluster and basically bring this together and aggregate and evaluate that. So the terms which come up here often is data plane on the collection side of things, and control plane on basically the aggregation side of things. And the advantage here is that this additional pod, or some term which comes here very often, is called a sidecar pod, like a sidecar in a motorbike. It doesn't drive on its own, but it kind of brings additional feature to the motorbike. Same here, is not added to the application container itself. So you don't need to rebuild the application. You don't need to rebuild the container. You basically just plug it in, and that makes it entirely independent of the framework or the application code of your application. Also, of course, you can easily put it in and out again. The only impact that your environment or like your service will have, that a pod will be restarted once if you add or remove an additional container. This is basically the runtime price that you have to pay there. And then you suddenly see the things. You basically see how applications communicate, who is basically talking to whom. You can also see what is the request rate, what is the latency, are the services actually talking at all, and so on. This can be really helpful. I mean, you have all the additional benefits of a service mesh, where you can say, I deploy version 2 of an application, and I route only 20% of the traffic, and 80% I leave with the old one, and things like that. This is something you can normally not do with Kubernetes. This will come in here, and you would, of course, also see it then. Now, for a 3-container kind of application, you probably don't need that. But as soon as your application gets bigger, it will certainly help you visualizing what is my kind of overall traffic behavior in such an environment. And it will also make it easier to understand for people that don't know what a pod or a deployment is. So this one basically helps a lot in that space. And as I said, it's pretty easy to try out. Now, one slide I probably skipped here is this thing, of course, comes with a different price. You don't really have a lot of impact on your application and your build environment and things like that, but you have additional network components in your traffic. So in a world before where service A would talk to service B, now service A talks to proxy A talks to proxy B, and proxy B talks to service B. That doesn't speed up your environment. So with this architecture, you certainly have an impact, as with everything once you put monitoring agents in. There are some measurements and graphs that I normally don't really like to show, because each application is different, and I can't say for sure how much impact you will have on your individual one. My recommendation case is more like, try it out. You can also do it partially, so you can say, I want to select this namespace and only inject those pods in that namespace, and then basically get a feeling for it if this technology is a thing for you or not. All right, as I said, it extends Kubernetes for the limitations in network traffic awareness and the traffic shaping by injecting such a sidecar proxy into each pod. I can try and see, no, this is too early, we're going to see that later. So this is Kiali. This is just one of the toolings that will be able to visualize that. And the environment that you see here is the OpenTelemetry demo application. So just to show you this real quick, let's go back to my good friend K9s. If I now go into the OpenTelemetry application, you can see that each of the pods has this 2 of 2 setting here. What that means, if I look into that, then I see I have the actual application pod and this proxy pod. So this is basically the way how it works. These proxy pods get injected, and they start then collecting and interacting with the traffic. As a result, you see all the flows and behavior. And of course, the bigger your application gets, the more difficult it might become. But then you can say, okay, what do I want to see? This is my namespace. I would like to see the response times. I would like to see the throughput. Very important is, of course, the traffic animation, because that makes it look really nice. So now you can see things are flowing here, and so on and so forth. And if you use like standard communication protocols like gRPC or REST, it will also highlight if you have like success rates, error rates, and so on here on the right-hand side. So it certainly can give you a benefit in understanding what's going on in your application. All right. Now, this one doesn't need to change the application or the container. But also the limitation here is, of course, as you're not in the application, you cannot get application level metrics. So while the first one, the initial step with the Kubernetes API can certainly be used for like sensing problems or figuring out something might be wrong, this one might be on a level where it can help you to isolate where things are wrong. And then you can look into the next step, basically deep diving into that problem and figure it out what the root cause is. Now, before I go in there, I want to talk quickly about an alternative solution to the one I've just presented. So this one I presented was about injecting things into pods. Another option would be to inject things into nodes. So basically, instead of placing the agents like listening here or here, we're now listening on the node level. How this can be done, and this is fairly new, it's not super new anymore, it's being exploited by a technology which is called extended Berkeley packet filter. Very difficult to pronounce. eBPF is the short form, you might have heard that. There's actually a Swiss company called Isovalent which is driving this very much with the Cilium technology, but they're certainly not the only ones. But they have shown ways how to leverage this, especially for a Kubernetes environment. Now I make a quick excursion into the world of Linux, and what you basically see here is a Linux environment which has a kernel space and a user space, and the kernel space is normally where your low-level code runs, things that basically make the core of the operating system, things that should always be running and never failing, and things that shouldn't be changed. So changing the kernel is something you really need to know what to do. eBPF provides a possibility to basically inject code into the running kernel. So one analogy that you probably have heard or might be keep hearing is eBPF for the Linux kernel is kind of what JavaScript is for a web page. So you basically run things in a certain kind of a sandbox environment where it can enhance the functionality, but where it cannot break out in a way that it is like harmful to the underlying system. So in this here, there is like an eBPF verifier that would validate the code, and before this is not done, it cannot be run there. But if it's done, it is a very elegant way to say, now I can change the kernel without waiting for any kind of updates or something. I can actually live inject things in there. And with that, you are able to grab kernel events. And for example, network events are such kernel events. So on a very deep level, you can like intercept the traffic and then send it to the user space where it's much easier to deploy things and can do evaluations and whatnot. And this goes back to the idea that every Kubernetes worker node, of course, is a Linux node. I mean, not everyone, but let's say that's like a vast majority. And so the kernel is, of course, sitting here on a very low level. But if you inject your code there, it will still get all the traffic that is executed on a higher level order on Kubernetes or container level. And what that means is if you use those agents, and I just like, this is just a sample sketch, that means you would have one eBPF agent on every node. And that is, of course, significantly different to having one agent in every pod. Because in a very normal case, you should have way more pods than nodes. If this is different in your environment, I would heavily challenge that. So that means the traffic overhead can, of course, be reduced by applying this technology. So this is, again, a screenshot, or I can also show this live. This is the so-called Hubble CLI. And let me just go to the main. So it will basically, once it's in the cluster, in this case, you cannot say I want it for this namespace only or that one, I don't want it. Once it's in the cluster, it's going to like grab all the traffic anyway. And I can make this a little bigger. So here you can see all my various namespaces. And once you jump into them, you also get this summarization and see who is talking to whom and what are the connections. With this one, of course, you can also monitor the things within Kubernetes itself. So you can say, I want to see what's happening in the kube system. You get the infos from there, and so on. So this has been a pretty hot topic, let's say, in the cloud-native technology space in the last 2 years, and it opened up several new possibilities, and I think there will be coming more. Now, with that, you suddenly also can use that information. This is now a screenshot of Grafana, where you can visualize those metrics, even down to like a tracing level, everything, but still, let's say, on the outside of containers. This is, I think, KubeShark. It's another tool that uses the same technology. And as you can see now, without changing too much in your applications or in your application containers, but by changing something or adding something to the nodes with the right privileges, you can quickly get into the network connectivity information of your clustered environment. All right, so to sum this one up, here we inject the proxy component on a node instead of a pod level. We use that Linux low-level functionality of eBPF for Kubernetes observability. Of course, this works outside of Kubernetes very well too. I mean, wherever you have a Linux environment, you can certainly do that. And still, the application and application containers remain untouched. So you configure a cluster once. Normally do that in the very beginning, and then you have it. Even like the big providers or the major hyperscalers are jumping on that train now. So I think I surely know it from Azure, and I'm not sure about the others, where you can, if you get like an AKS cluster, you can already get it pre-configured with that technology enabled. That is, of course, a big advantage then, because then it's outside the scope of your own management. So you don't own that stack, you basically consume that as a service. Okay. To get things finalized, we now look into the more application-based monitoring, where we basically place agents in or around, I should probably say, our application. So this little thing here is supposed to be my monitoring agent in the application. It looks very simple on the chart. In reality, it's not so much. Because once you go into the application, of course, you need to have domain-specific or language-specific or framework-specific agents to know what to collect. Otherwise, it's not going to work. From an architecture point of view, of course, this is going to put it into some database. This, again, can be Prometheus and Grafana as visualization, but of course, there is a variety of tools. Now, the problem here is you have many different application frameworks, and you also have many different solutions to query, to collect, to format, to store, and to visualize information. So I don't really want to go too much to this. I mean, Nele has shown something today with micro and mentioned OpenTelemetry. OpenTelemetry is also the tooling that I would probably highlight here today, because this has taken a very, let's say, healthy evolution. If you look at that cloud-native landscape, you can basically see that for each problem you have 100 solutions. And if you look 2 weeks later, you probably have 200. Now, OpenTelemetry is basically a merge of 2 original different open source projects. So it's actually combining things and reducing the amount of options that you actually get. Now, the way that it works, I should probably say it's not like a full-blown and holistic observability solution. OpenTelemetry most focuses on the level of data collection and trying to make sure that the way your traces and metrics are formatted do basically comply with a certain standard. So many different tools can actually use it and evaluate it. I mean, I've been in the IT industry even before that microservice and distributed systems kind of, or distributed applications wave. And I remember very well when we used to have monolithic applications. I'm basically, my background was in the J2E or Java EE space. And back then, the vendors of such a monitoring solution, of course, made their thing very proprietary. I mean, the goal was, of course, to have like to get the client locked in and have your own solution basically spread out across the entire company, which makes sense from a vendor perspective, which is not so great always from a client perspective. Now, with the change of application being more polyglot. It was and more distributed. It was kind of harder for those to get into the environments and spread out in this way and basically maintain their ground. So actually, OpenTelemetry is backed up by open source committers from major vendors of observability solutions. So for the sake of the clients, they have decided to go into one direction and standardize the format of data collection. And then later on here towards the right, when it's being sent to any kind of API front end whatsoever, then the competition between those can be done on the evaluation level of the data, much rather than on the collection level. This is not so bad for us as consumers, and it provides also the possibility to get involved here and contribute own instrumentation, own solution. In the end, it just need to make sure it complies with that specification. So I really hope this works out. And I think Nele said this before. This is the project in the CNCF space with the second highest contribution after Kubernetes. So there's certainly something going on, and I hope there will be more around in that space in the future. Now, how does that work? How am I going to get my OpenTelemetry agent software into an application? There's, of course, as I said before, you have a certain language coverage here. Not everything will work because you now have to go into the application. Now, there is instrumentation support for, let's say, the most popular languages. And for a subset of the most popular languages, there is also some kind of automatic instrumentation. I will show you in a second what that means. This is a Docker file of a pretty simple Docker file from a Java application, where you can see what I'm doing here is I'm having this add command, which you probably normally don't have, which is downloading the latest OpenTelemetry jar file, and then it's copying the application code into the container, and then it's running it's invoking the Java command and is attaching this Java agent. So this is still also, let's say, the least intrusive way to add something to a Java environment. Why? Because you don't have to rebuild the jar file. So it's like you have to rebuild the container, but you don't have to rebuild the jar file. Additionally, you need some configuration of your application then, because the instrumentation jar, of course, needs to know where do I have to send my data to, and also it has to give some information about the application itself. So what is my name, and where do I send the stuff to? You can do it differently, though. As I said, it's pretty open. There are different solutions. So this is like a Spring Boot dependency for using Sleuth as the data collection within your application. Same thing here. You need to configure your Spring Boot properties. It's basically the same concept all the way through. And you have that for Quarkus. I'm pretty sure for Micronaut, for most of the for the popular frameworks, and of course you have the generic Java agent as well. Now, once you do that, you can start getting metrics and information of your application which are client specific. So here we can see JVM metrics in Grafana now, where we see the garbage collection history, the threads and things like that. So this is something like a service mesh would never be able to give to you because it just doesn't know what is in the container which is next to the sidecar. And there's more. I mean, I don't want to read through all of those, but you probably believe me, this is all true. Now, one final thing I'm going to show is the technology of Jäger. This is, I'm not presenting in German very often, but it's a German word. Yeah, it's Jäger, which is like a visualization for distributed traces. And this was there before OpenTelemetry. It can certainly be used without OpenTelemetry. But I would probably say it got a lot more popular now through OpenTelemetry because it can show the information there pretty easily. Now, this, for example, is a Jäger screenshot without using OpenTelemetry. This is one where I use only a service mesh. So I have a pretty simple application, a UI which calls a backend, which calls a database. With the service mesh, I would only be able to see this. Basically, how much time is the overall time in the application, and how much is it in the nested part where it invokes the database. This is how it would look if you have application level monitoring. Now I can see the REST calls, I can see the name of my application, my methods, and then also this is using Spring Data API. As you can see the calls here, and then the select statements in the database. So you can get down to this level, and this is an example of the auto instrumentation. Now the auto instrumentation, as the name says, can only auto instrument. It has to guess kind of which methods with things am I going to look into. If I have an infrastructure, like an application infrastructure, where I have methods which are not being filtered out here, then you can certainly do that. So this is a sample code where I would normally just do the above part. So I have a post mapping. I'm going to add a to-do to a REST endpoint, and then let's say save it to a repository. Now I added in this kind of some useless method that I would never need, which processes this save part. This is something that would not show up in my traces right here. I would only see the save method, which would then jump into the SQL part. Now with this annotations, with the OpenTelemetry dependency gives me, I can now say, okay, I want to add a span, like a with span annotation, and a span attribute. This means it would tell OpenTelemetry to like monitor this method, individual method as well, and log out the actual value of the span attribute when it's being collected. So now rerunning this would actually show, okay, this is the method right here. I'm seeing that now too. And once I expand it, I also see the value of that parameter. This can be very helpful if you have an error that just occurs sometimes and sometimes not, which is most likely, or unfortunately often the case. So with this, you can try to figure out if you have certain patterns in the actual variable state of that call, which might be different from others and cause that problem. All right, so I'm about to come to an end. As I said, unfortunately, there are too many different solutions out there. My colleagues at Novatec have written this thing called OpenAPM kind of website, where it checks for compatibility between different monitoring solutions. So who is able to feed data into whom, who is able to talk to which database, so you can try to figure out which kind of combination is actually supported. If it makes sense technically, is of course not able to be validated in on this website. Now, to wrap things up, we got application level metrics here. You can do root cause analysis. You can down to like variable level within your application. But of course, here you need to change the application. The more you monitor, the more overhead you will certainly have. And it's specific to the programming language and framework, but there is already some pretty decent coverage. All right, so in this talk, of course, I only went into open source solution. I didn't really want to make a pitch for any of the vendor solutions out there. I mean, they would probably come with an overall set and try to give you all the things here combined. This was not my intention. My intention was way more to give you a feeling of how much do you have to get into an application or into your changes in your application to get out what kind of information. All right, if you liked it, this is the slide deck on Speaker Deck. You can download it. I'm probably post a link later on Twitter again. As I said, the full length, the 3-hour version of this talk with various live coding examples and basically a deeper walkthrough to the technologies here can be found on YouTube. And with that, I would like to say thanks very much for having and listening to me. Am I good in time? Okay. So yeah, feel free. I'm going to be still around until 6 or something. Grab me for a drink if you want. These are my connection details, and feel free to talk to me.